We will use this point class to learn how to write classes and how to understand the concept of instance variables. This point class is different from the point class in the graphics module. In Python 3.7, you need to add this import statement to specify a type annotation for a class that is defined in the current file. In future versions of Python, this import line will not be necessary. You declare a class using the keyword class, followed by the name of the class and a colon. By convention, the name of classes are capitalized. This makes it easy to distinguish between class names and function names. The methods for the class are indented underneath it. The main function here is not part of the class, since it is not indented underneath the class definition. The point class has 5 methods and 2 instance variables. The double underscore init method is the constructor. It is called when we create a point object. The name of the constructor for every class is init with a prefix and suffix of 2 underscores, and is usually the first method you write underneath the class definition. Any methods that start and end with 2 underscores have a special meaning in Python, so you should not name your own methods using 2 underscores. The double underscore str method is a special method whose purpose is to create a string representation of an object. It is called when you use the str function to convert an object to a string, and when you print an object, since that needs a string representation of the object. For the point class, I wrote 3 additional methods. The first parameter to any method is named self by convention, and its type is the type of the class. In this class, the first parameter self will always have the type point. The data before the period when calling the method is the one that is passed to self. Remember that we create an object of a class by using the name of the class and passing any parameters needed to initialize the object. In this example from the main function, we create a point using the parameters 2 and 3. When this statement is executed, the class's double underscore init method is called to create the object. The variable we are creating is passed as the self parameter, so p1 will be a point object, and the point constructor takes 2 additional parameters representing the coordinates of the point. 2 is passed to x, and 3 is passed to y. The data for an object is set using the parameter self. Generally, you want to initialize all the data for the object in the constructor. The data that the object consists of are known as instance variables, and are designated by writing self dot in front of the variable name. Note that x and self.x are 2 different variables. In this case, x is a parameter, and self.x is the instance variable. When a function or method ends, regular variables and parameters go away, but the instance variables continue to exist as long as the object exists. We created the point p1 in the main function, so as long as p1 continues to exist, its instance variables p1.x and p1.y continue to exist, so when we call methods with p1, the current value of those instance variables are used. We'll see this when we step through this example. The double underscore str method is called when we print an object or use the str function to convert it to a string. If we do not write this method, Python would return a string stating it is a point object at some specific address. By writing this method, we can produce a string that is better formatted and has more useful information. In this case, we will return a string that has parentheses around the x and y values of the point. Note we use the instance variables self.x and self.y. Unlike regular variables in a function, we do not need to assign these instance variables a value before using them, as they will have the values for the point with which we called the method. The moveBy method takes 2 additional parameters that indicate how much to move the point. Again, we do not need to give initial values to self.x and self.y, as they will have the values of the point with which we called the moveBy method. We update the instance variables by adding the corresponding amount to each coordinate. Since we changed the values of the instance variables, this is a mutating method that changes the data for the point with which we called it. The distance_to method takes an additional point and returns the distance between the point with which we called the method and the other point that is passed as a parameter. We need to get the difference between each coordinate and save those values in dx and dy. Note that since the parameter otherPoint is also a point object, we can write otherPoint.x and otherPoint.y to access the data for it. Also note that we did not write self.dx or self.dy. The difference between this point and the other point should not be part of the data for the point. The variables dx and dy are only needed as temporary values to help us calculate the distance between the 2 points. Once the method returns, they will no longer exist. Remember that generally all instance variables should be created in the constructor, so you should not be creating new instance variables in other methods. Also think about whether the data is part of the object. In this case, dx and dy should not be part of the data to represent a point, so we do not put self dot in front of them. The clone method does not take any additional parameters. It returns a new point object that is an exact copy of the point with which we call it. Again, we can access the instance variables without giving them values because they have the values for the object with which we call it. Since we call the point object's constructor, we get a new point with the same coordinates as this point. We'll debug this and it stops at the breakpoint in the main function. This line creates a point, so it will call the constructor. We'll step into it and see that the double underscore init method was called with the parameters for x and y. The purpose of the constructor is to create and initialize the object, so all it needs to do in this case is set the instance variables to the values provided by the parameters. When we step over the last line and step over one more time in the main function to complete it, we can see that p1 is a point object and has instance variables 2 and 3. PyCharm uses the point class's double underscore str method to display the string representation of the point. We'll step over this next line that creates a second point named p2. We can see that we now have two separate points, each with their own values for the instance variables. We're now at the call to the distance2 method. When Python executes this statement, it checks the type of p1 and determines that it is a point object. It then checks if the point class has a method named distance2, and if so, calls it. If it does not have a method with that name, it crashes. We call it with p1, so p1 will be passed as self, and p2 will be passed as the parameter otherPoint. Note that when you call a method, you always pass one fewer parameters than are in the signature, because the object before the dot is supplied as the first parameter self. We'll step into the call to the distance2 method and see p1, which is the point 2, 3, is passed to self, and p2 with coordinates 5, 7 is passed to otherPoint. Since they are points, we can access their instance variables using the dot notation. The local variables dx and dy are used to help compute the result, but since they are not part of the data for the class, we do not use self when creating those variables. When the function ends, dx and dy will go away. When we finish stepping over the function, we can see that d is assigned the return value of the method, and we print it to the console. Remember from the videos covering the graphics objects in Chapter 4 of the book that assigning one name to another name makes both variable names refer to the same object. Both p2 and p3 are different names for the same point. We'll step into the call to p3.moveBy and see that the data for point p2 and p3, which is 5, 7, is passed as self, and the values 2 and 8 are passed to x and y. Since we are modifying the instance variables of self, this is a mutating method. We call the method with the variable p3 from the main function, so p3 will be changed by this method. After we return from the function, we see that p3 is changed, and that since both p2 and p3 refer to the same object, p2 also reflects those changes. We'll step into the call to print p2 and see that when printing an object, if the class for the object has a double underscore str method, that method is used to create the string. Since we printed p2, p2 is passed to self, and it creates the string with parentheses around the coordinates of p2. When we complete the function, we see that it outputs that string. If we want to create a string representation of the object without printing it, we can use the str function. Just as the print function calls the double underscore str method, using the str function calls the double underscore str method. Python checks the type of p2, and since it is a point, it calls the point class's double underscore str method, with p2 passed to self. When the function returns, we see that s is the string representation of p2. Note you should not call the methods that begin and end with two underscores directly. Just as we use the name of the class to cause the double underscore init method to be called, we use the str function to cause the double underscore str method to be called. We saw that assigning one variable name to the other created two names for the same object. If we want separate objects, we could do as we did with p1 and p2, and call the constructor each time to get two objects. The point class contains a clone method that does this. We'll create p2 and then call the clone method with p2. We see that p2 is passed to self, and since this method calls the constructor, we are creating a new object with the same coordinates. The clone method returns the new object. Back in the main function, p2 and p3 are now two separate objects, each with the same data. When we move p3, p2 does not change. We can print them both out to see they are two different objects.